Imagine a giant library where every book is tossed into an unsorted pile. Finding one book takes all day. 5 things. Why arrays fail at 100 million transactions per day. O(n) scan on every payment is catastrophic. How hash maps achieve O(1) lookup using hash functions. 3 PhonePe applications, idempotency store, VPA cache, and rate limit counters. The O(n) space trade-off and the interview decision matrix. Let us go. Imagine checking idempotency by scanning a flat array of all recent transaction records. Each payment triggers a linear scan from index 0 until finding a matching idempotency key or reaching the end and confirming this is a new payment. 100 million transactions on average, 50 million comparisons per check at 1200 transactions per second peak. This is 60 billion comparisons per second. The CPU burns out before it can keep up. Hash map replaces the O(n) scan with a single hash function evaluation and bucket lookup. O(1), the hash of the idempotency key maps to a bucket. 1 comparison. Done. Regardless of whether the store has 10,000 or 10 billion entries, the lookup time stays constant. Use case 1. Idempotency store. Payment service checks Redis hash for the idempotency uuid. HGET in Redis is O(1) key found. Return cached result without processing. Key absent. New payment. Process and cache result. This is the primary use case for hash maps in payment systems. Use case 2. VPA resolution cache. API gateway checks Redis for VPA to account number mapping. VPA is the hash key. Account number is the value. Cache hit return account number in under 1 millisecond. Cache miss query npci VPA registry and write back. 80% cache hit rate on VPA lookups. Use case 3. Rate limit counters. API gateway increments a per user sliding window counter on each request. INCR in Redis is O(1). If the counter exceeds the limit, say 5 payment attempts per minute, the request is rejected with HTTP 429. The key includes the user ID and the current 1 minute window timestamp. Redis EXPIRE sets the time to live to 1 minute, so the counter auto resets. Full hash map usage in a PhonePe payment. All 3 use cases, rate limit, idempotency, VPA are O(1) Redis hash map lookups. Hop 1. Payer sends payment request with idempotency uuid and payee VP. Hop 2. API gateway checks rate limit counter in Redis. Under limit, proceed. Hop 3. Payment service checks idempotency. Store, cache miss, new payment. Hop 4. Payment service resolves VPA from Redis. Cache hit, account number returned in under 1 millisecond. Hop 5. Payment processed, transaction returned to PostgreSQL idempotency. Result cached in Redis. Hop 6. Payment confirmed. All hashmap operations were O(1) total Redis latency under 3 milliseconds. The hash map versus array decision matrix for payment systems. Use a hash map when you need O(1) key to value mapping, idempotency store, VPA cache, rate limit counters. Use a plain array when access is always sequential. A list of recent transactions displayed in order, where you always read from index 0 to n. Use a sorted array or B tree when you need range queries, transactions between date A and date B, which requires O will log n. Search. The space cost of Redis hash maps at PhonePe scale. 100 million idempotency keys at 64 bytes each is about 6 gigabytes distributed across a Redis cluster with replication. Hash maps give O(1) lookup at the cost of O(n) memory. At PhonePe scale, 100 million transactions per day, O(n) array scan is CPU prohibitive. Redis is the production hash map for 3 critical use cases: idempotency store, VPA resolution cache, and rate limit counters. All 3 Redis operations, HGET, HSET, INCR, complete in under 1 millisecond regardless of dataset size. Next video, linked lists and LRU cache through the PhonePe lens. Your recent transaction screen always shows the latest first. Implementing this with a doubly linked list plus hash map gives O1 access, and O1 eviction. 8 minutes. Subscribe to ByteLearn for 1 DSA concept per week through the lens of PhonePe. Under 8 minutes, interview ready, hit the bell. See you Monday. Question: what's your favorite problem to solve using a hash map?